Hello Math 7 students, this is Open Up Resources, Unit 4, Lesson 8, Percent Increase and Decrease with Equations. To get started, we have this quick poll as a warm-up. Please pause the recording until you have your answer, and only continue the recording when you're ready to go over it. When I read this, I'm looking for pieces of information like what's the original and what's happening to that amount. So strawberries are $2.50 per pound. That tells me what they originally were. This right here is the original price. There was a terrible storm that damages a whole bunch of strawberry plants. So that means the supply has gone down, and to kind of account for that, the price has to go up. The price increases 40%. So what is the new price of strawberries? When I'm asking what is the new price, that means I don't care how much it did increase. Like, I don't want to know the cents or dollars that it increased. I want to go straight to what is the new price. Based on our previous lessons, that means I know if it increases 40%, that is 100% plus an extra 40%, which is now a new total of 140%. That means strawberries are 140% of the original cost. And so I type into my calculator exactly this. 140% as a decimal is 1.4. Or if you want, 1.40. Of means multiply. And the original amount is $2.50. That's what I should have typed into my calculator. When I do that, it gives me the new amount. So what is that new price? 1.4 times 2.5 is equal to 3.5. Since we need to make it quantitative, 3.5 when we're dealing with dollars means $3.50. When you type it into your calculator, it doesn't allow you to type in the dollar sign, but you could have typed in 3.5 or 3.50. This should be part of your notes. Remember that calendar that I showed you? We're testing sooner than you realize. You need to make sure you're solid on this. Probably at least 35 to 40% of the questions are going to be like this. Okay, this is important that you know this. So please make sure you're practicing, make sure you're taking notes, make sure you're using them from day to day. For this lesson, it is called Percent Increase and Decrease with Equations. As we get started on this lesson, we do have some interesting questions here. Normally, I would go over them, but looking at the clock in class, I can see we're going to run out of time if we spend a whole lot of time on this, so I am going to skip this warm-up portion. We're going to move on to the next set of problems, starting here. It says 8.2, Interest and Depreciation. Money in a particular savings account increases by about 6% after a year. How much money will be in the account after 1 year if the initial amount is $100? Or what if it's $50? Or $200? Or $125? Or X dollars? Now, I want us to make sure that we pause and understand that this is related to what we saw here. Okay? I only want to make some small little alterations. So, do we know what the initial amount is? We can see it's changing for each portion of this problem, right? Do we know what's happening in this problem? You've invested money and you get an increase of 6%. So do we know what's happening in this problem? Yeah. So let's approach this in the same way that we did our warm-up. Don't worry about this part just yet. We know that if we have 100% of our money, but then it increases 6%, we end up with 100% plus 6% is equal to 106%. 106% of what? Just like we wrote down here. I wrote 140% of the original. So what am I going to write here? 106% of the original. What is the original? Well, it changes for each part of this problem, right? But I do know that 106% of the original, what is 106% written as a decimal? Gabriel? Yes, 1.06. And of means to multiply, and the original amount, well, it changes each time. What is it the first time around? 100. Let's write that down. Type this into your calculators then. 1.06 times 100 is equal to, what is the new amount? Bridger? 106. Okay, that takes care of this one. We did $100. What if instead of $100, what if it's $50? What change do I need to make? Do I need to change this 1.06? No, that's staying the same, right? The only thing that's changing is instead of $100, I only have $50. What is it going to be if it's $50? So now we know what to type in. 1.06 times 50 is equal to what, Riley? 53. Let's keep on going. I know I'm going to run out of space, so I'm just going to copy all of this down over here into another column. Let me lock this in place. %106% of the original, so that's 1.06 times. Let's move on to the next one. Oh, I did 50. Let's move on to the next one. The next one is 200. So 1.06 times 200 is equal to what, Michael? $212. What if instead the original amount is $125? Notice the 1.06 isn't changing, right? 1.06 times the new amount now is 125. Type it into your calculator. What is that going to be, Aaliyah? You guys get the same thing? The other ones I could do in my head. That one I couldn't do, so thank you for checking. 1.06 times 125 is equal to $132.50. I've now done those. What is going to change now if it's X dollars? What's going to change? Luis? Yeah, exactly. Instead of changing this to a number that we know, I'm going to use the symbol X. So 106% of the original, but what's the original amount? X. What is that going to be equal to? We can call it Y, right? Why did I choose Y? Why did I choose Y instead of putting a number there? Luis? Yeah, because it's getting multiplied by a symbol, something that we don't know. It's going to be equal to another symbol, something that I don't know. Exactly. So, guess what we just wrote here? We wrote an equation, right? We've seen equations similar to this before. If all you had is this equation, would you say that this equation is representing a proportional relationship or not? Talk with your groups. Would this be a proportional relationship? Talk with your groups and review everything that you know there. Okay, and now come back to me. Would you say that this is proportional, Emily? Exactly. Remember, proportional equations, all we have is multiplication. What do we have here? Just multiplication. X multiplied by a number is equal to Y. So guess what? This would be proportional. So here's my next question then. What is the constant of proportionality? What is the number that we are multiplying by? 1.06. Keep that in mind. That's going to come up in tomorrow's lesson. X is being multiplied by 1.06. That makes this the COP. It's a good connection to tomorrow's lesson. Let's move on to the next one. The value of a new car decreases by about 15% in the first year. How much will the car be worth after 1 year if its initial or original or starting value was $1,000? What if it's $5,000? What if it's $5,020? What if it's X dollars? Again, it says if you're stuck, use a table or diagram. I like organizing our information just like we did before. So I'm going to pause here, let students work on that one in class, try and follow the same strategy as what we did before, organizing it in a similar way, and things will be a lot easier for you. Work with your groups. I'll be wandering. So make sure you're raising your hand if you have questions, pausing the recording now. Ready, set, go. What do I do with this? How do I get started? Caitlin? It's decreasing 15%, so start there. What does that mean if it's decreasing 15%? What do I do with that information? Do I need to come back to you? Yeah. Okay. I tried. Gabriel. Great. Pause there. Since it is decreasing 15%, that's 100% minus 15%, which is equal to 85%. What do I do with that now? Take one more step for me, Gabriel. Hold on one second. Before that, I want to make sure I take the time to write this statement. 85% of the original. Yes. And so, with this statement written, 85% of the original, what do I actually write down? What am I going to be typing into the calculator? Let's go to Seth. Great. 0.85. 85% is 0.85, or 85 ending in the hundreds place. Of means we are multiplying, and we are multiplying by the original. What is the original? Depends on which time, right? First time it's 1,000. So 0.85 times 1,000 is equal to the new amount, Caitlin, $850. Ooh, I need to fix that. I didn't write that correctly. 1,000. Done. Check. Let's move on to the next one. What if instead of 1,000, what if the initial amount is $5,000? Then that's going to be 0.85 times 5,000. What is that when I type that into my calculator? Kale. 4,250. You guys get the same thing? Great. And now that takes care of that one. What if instead of 5,000, what if it's just a little bit different, 5,020? 0.85 times 5,020. And what do we get, Trace? Please double check. You should have typed in 0.85 times 5020. What do you get, Luis? $4,267. What if instead of 5,020, what if it's just X dollars? What do I do now? Stephen? Yep, 0.85 times X. X is whatever that original amount is, and what is that going to be equal to? Y, because we don't know what that is either. Okay, that represents that original amount. Take the original amount, multiply it by 85% or 0.85, and we get the new amount. With that in mind, you're getting pretty good at writing those equations now, right? Yeah. So let's do some matching. Here's a situation, and here are some equations. We need to figure out which equation matches with which. Okay? The water level in a reservoir is now 52 meters. If this was a 23% increase, what was the initial depth? Do we know what the initial depth is? No, we don't. And since I don't know what the initial depth is, what do I use? X, a variable. The initial, depending on which resource, sometimes they'll use the word initial, sometimes original. So I've been using original, but initial means the same thing. So what was the original or initial depth? Do we know? No, we don't. So kind of like this. We didn't know what it was in the very beginning. We said, what if it's X, right? But what happened in this problem? The amount of water in the reservoir increased 23%, right? It increased 23%. If something increases, what do we do to show that increase? For example, what did we do here when it increased? We did 100% plus 6%. So now if it's increasing, that's going to be 100% plus 23%. And what is that going to be? 100% plus 23% is equal to, Caitlin, 123%, right? So are we going to change the process that we've been through all these other times? No, our process doesn't change. It was an increase, eyes on the screen, 100% plus 23% is 123%. What do I do with that? That means 123% of the original. Do I know what the original is? No. Do I know what the new amount is? Let's read it again. The water level in a reservoir is now 52 meters. That's a 23% increase from where it was. Do I know where it was? No. Do I know where it was? No. Do I know where it currently is? So do I know this new amount? Yes, I do. So 123% of the original, which I do not know, is equal to the new amount. Fun fact, that new amount is 52 meters. I would say why if I didn't know, but since the problem tells me that it's 52, I don't need to use a symbol because I know the amount. So let's translate this from English to mathematics. 123% is 1.23. Of means multiply. Original, do we know what the original is? No, so we're multiplying it by x. What is that going to be equal to? The new amount, which is 52. Which equation does that match with then? 1.23x equals 52. This is problem number 1. Here's what I want you to recognize. This is something that my other class struggled with, and I don't want you to have the same struggle. All of these problems up until now, we've known the starting amount, and we use it to find the end amount. In this problem, I know the end amount. That doesn't mean I start with the end amount. It means I still end with the end amount, and I have to work backwards to try and find that new amount. Okay, our process doesn't change. The snow is now 52 inches deep. If this was a 77% decrease, what was the initial depth? Take a second with your groups and figure out, what do we know? What are we trying to find? Label them as original and new. Okay, label them as original and new. Start with that, discuss with your groups, and we're just going to keep this recording going. Okay, now come back and let's try and discuss as a class. The snow is now 52 inches deep. That might sound like something, but if I keep on reading, I continue to see that this represents a 77% decrease. So I'm really asking, what was the initial depth? So based on that, 52 inches, is that the original amount or is that the new amount? Yeah, this is the new amount. When it's a 77% decrease, what do I do with that information? If it's a decrease, what do I do? Luis. Exactly. If it's a decrease, we subtract it. 100% minus 77% is equal to, Trace, 23%. Let's keep on reading. What was the initial depth? Do I know what the initial depth is? No, that is exactly what it's asking. That means I don't know where it started. I don't know the original. What do I do instead then? We use a variable. What do I do with this? Whatever I do, I like to write out this equation. It really helps me out, right? So 100% minus 77% is 23%. So that means 23% of the original. When I do 23% of the original, that is going to give me the new amount. What is that new amount? 52 inches. So let's write this out. 23% is 0.23. Of means we're multiplying. What is the original amount? Emily? X. We don't know, so it's a variable x. What is it going to be equal to, though? The new amount, which is, Luis, 52. There's our equation. Do you see that? It's this one right here. So this is problem number 2. So now the question is, how do we find these original amounts? Because we didn't know the original in either one. In problem number 1, we have this equation. I'm just going to write it right here. 1.23x equals 52. What's happening to x? Talk with your groups. There's not enough hands. What's happening to x in this equation? I think you're ready to come back to me now. What's happening to x in this equation? Caitlin? Yeah, it's being multiplied by 1.23. How do I undo multiplying by 1.23, Aaliyah? We divide by 1.23. Whatever I do to one side, we do to the other side. So what do I have? X, which is the original amount, and what is it equal to? Type it in. 52 divided by 1.23. 52 divided by 1.23. Either your hand is up because you've already typed it in and you know, or your hands are busy typing it into the calculator so you can find it. Gabriel. Let's just go one decimal place. 42.27. 27 would make the 2 round up to 3. So I'm going to call it 42.3. What was the original amount then? 42.3 meters. Problem number 1 was meters. So, did I know the original amount? No, but if I don't know, I work backwards, right? We can work backwards and still find it. So let's do this next one. Problem number 2, we use this equation, 0.23. X equals 52. What is happening to x in this equation? Emily? Yes, it's being multiplied by 0.23, and I undo multiplication with division. Whatever I do to one side, I do it to the other side. And I end up with x equals, and I am typing into my calculator. Not waiting for someone else to do it, not waiting for me to write it up on the board, 52 divided by 0.23. Riley? 11.96. X is equal to 11.96. 11.96 what? Inches this time. So what was the snow depth originally? Ooh. I think you need to double check actually. Did you do multiply, Riley? Let's make sure we type that in the right way. What did you get, Alexis? 0.8, and 0.8 is going to make that 0 round up to 1. Yes, that makes a lot more sense. Because if it's 226.1 and it decreases a whole bunch, 77%, that would make sense to get us down to 52. So what was the snow depth initially? 226.1 inches. Okay, nicely done. For the sake of time, we're going to skip the Are You Ready for More? I do want us to take a look at this next problem. So 8.4, representing percent increase and decrease equations. Our last lesson was working towards those equations. Now we're officially here. The gas tank in Dad's car holds 12 gallons. The gas tank in Mom's truck holds 50% more than that. How much does the gas, or how much gas does the truck's tank hold? This situation can be represented by this equation. Why? Let's break it down. Where does this 12 come from? Where does that 12 come from, Kale? Yeah, because that's what we're comparing to. That is our original amount. Where does this 1.5 come from? I don't see a 1.5 anywhere in this problem, right? So where does that 1.5 come from? Luis? Yeah, because it is a 50% increase because it's 50% more. So where does it come from? 100% plus 50% is equal to 150%. What does that really mean? 150% means 1.5. And in the end, what is it equal to? Do we know? No, because that is the new amount, or in other words, it's the amount that's in the truck. So we were comparing the truck to the car, so the original amount is the car. The new amount is the truck. With that in mind, we're going to finish up here. Let's write an equation for A. That's all we're going to have time for. A movie theater decreased the size of its popcorn bags by 20%. If the old bags held 15 cups of popcorn, how much do the new bags hold? When I say the old bags, is that the initial? Yeah, because it's how it used to be, right? That's how it was in the beginning. So this is the initial or the original. Do we know how much they hold now? No, that's what it's asking. So we know what our variable needs to be, right? New amount is question mark, or we could say N for new amount. What's happening though? The amount decreased. So that is going to be subtraction. 100% minus 20% is equal to 80%. So what do I write down? 80% of the original is equal to the new amount. Let's fill in these spots then. 80% is 0.8. Of means we are multiplying. What is the original? Nope, we know it this time. The original is 15. What is it equal to? We could say X. That's fine. We could say Y. That's fine. I like N for the new bag. It just has to be a variable. We don't have to be picky about what that variable is. But now we wrote an equation. Can you solve it? It's already solved. N is alone, right? So what is the value of N? We just type it into our calculator. Oh yeah. All right. Let's type that into our calculator. 0.8 times 15 is equal to the new bag size. The new bag size is 12 units of measure cups. So 12 cups. Repeat that process for B and C. Make sure you pause and take enough time to figure out what is the question really asking for. What information is it giving us? Is it giving us the original amount? Is it giving us the new amount? So pause the recording, try B and C on your own first, and then we can go over them. All right, part B. After a 25% discount, the price of a t-shirt was $12. What was the price before the discount? The way the question is worded, when it's asking what was it before, that means in the beginning, we don't know. That is the original amount that we do not know. But I do know that the price of a t-shirt is $12. That is the new amount because that's where it was after the discount. So after that discount, that's when it is $12. This discount of 25% gives us 100% minus 25%, which is going to be equal to that 75%. Right? So we are going to be writing 75% of the original. When I do 75% of the original, that is going to be how I find the new amount. And so we can just translate and write that equation. 75% is 0.75. Of means we're multiplying the original amount. That's the thing that I don't know. So we're going to use a variable. I like x. And when I do 0.75 times the original amount, whatever that original amount is, it is going to give me the new amount of 12. Based on that, we now need to solve this equation. X is being multiplied by 0.75. I'm going to undo that multiplication with division. Although these problems do not ask us to solve them, I think it is a good idea to do that. We have our equation, now let's solve it. I undo that multiplication with division, so I will divide each side by 0.75, and whatever I do to one side, I do it to the other side. So this leaves me with, I'm out of space, so I'm just going to rewrite it over here. It leaves me with x all by itself, and x is 12 divided by 0.75. Type that into my calculator, and I get x is equal to 16. Again, what that means is before it was discounted, the original price of that t-shirt was $16 in the beginning. When we get that 25% discount, that's when it is only going to cost us $12. C. Compared to last year, the population of Boomtown has increased 25%. The population is now 6,600. What was the population last year? When I'm asking what it was before, that means we don't actually know the original amount. But I do know that it is now 6,600. That means that is the new amount. So when we see this, it's increasing 25%. That would be 100% plus 25%, which is equal to 125%. That's 125% of the original. And when I do 125% of the original, it will give me the population, that new population. So let's translate this from our English to mathematics. 125% is 1.25. Of means we're multiplying. And the original amount in the beginning of this problem, we don't know. That is what the question is asking. So we're going to use the variable. What is it equal to? It's equal to the new population. And it tells us the new population, what it is now, is 6,600. So this is the equation. With this as the equation, we now need to solve it. We can see x is being multiplied by 1.25. I undo multiplication by dividing and balance it doing the same thing to each side. When I do this, 1.25 divided by 1.25 divides out, and I'm left with just x. X is equal to, in my calculator, I will be typing in 6,600 divided by 1.25, and I get x is equal to 5,280. What was the population last year? The original population last year was 5,280 people. And now we have made it to our summary. Here's the big takeaways. We can use equations to express percent increase and percent decrease. So if y is 15% more than x, this demonstrates it very, very nicely. This would represent the 100%. This represents the extra 15% since it's more. And 100% plus 15% is equal to 115%, which I would use the decimal 1.15 to calculate, which is what we see here. That is being multiplied by the original amount. Notice this original amount is listed as just x. So that 1.15 is multiplied by x, which is how we get this. We can see the same type of thing in the next model. If A is 7% less than B, we would still start with our 100%. You can see that is B, and that is 100%. But if it's 7% less, that means this amount here is that 7%, and that is how much it is being reduced. 100% minus 7% is equal to 93%. Well, that 93% is written as the decimal 0.93. What are we going to do with that? We multiply it by the original amount, which we don't know. They're using the variable b to show the original amount. That is how we are getting to these equations. So even if I know the new amount instead of the original, we can still solve for that. We're going to skip the cool down for the sake of time, which gets us to the practice problems. Your homework is the Lesson 8 practice problems. That's it for today's lesson. Thanks for watching. We'll see you next time.